Your turn. Given this batch of numbers as displayed on a TI89 and their associated units, see if you can interpret the number in both base units and proper engineering format. Again, both base units and proper engineering format. By all means, pause the lecture and try this yourself. If you're tracking, you should have obtained the following values. 47e negative 6 means take 47 and multiply by 10 raised to the negative 6, or 0.000001, which is 0.000047. If you're using engineering prefixes to represent this quantity, I could say this is 47 microfarads. 3.9e3 means take 3.9 and multiply by 10 raised to the third, or 1,000. 3.9 times 1,000 is 3,900. The engineering prefix associated with 10 raised to the power of 3 is a kilo, so I could say this is 3.9 kiloohms. 70e negative 3 means take 70 and multiply it times 10 to the negative third, or 0.070 amps. The engineering prefix associated with 10 to the negative third is a milli, so it's more appropriately expressed as 70 milliamps. 680e0 means take 680 and multiply it by 10 raised to the 0, where 10 raised to the 0 is 1. Anything raised to the 0 power is 1. 680 times 1 is 680 ohms. Given we're already at the base unit of ohms, the engineering prefix is unnecessary, and this would most naturally be written as 680 ohms. Our next entry, 22e negative 9, means take the coefficient 22 times 10 to the negative 9th. In the base unit of farads, this represents a quantity of 0.000000022 farads, more appropriately expressed in engineering format as 22 nanofarads. The next entry, 2.3e6, means take 2.3 and multiply by 10 raised to the 6, or million, or 2.3 million watts. The engineering prefix associated with the power of 10 to the 6 is a mega, so this is more appropriately expressed as 2.3 megawatts. Lastly, 1.15e9 means take the coefficient 1.15 times 10 raised to the 9th. So this is more appropriately expressed as 1.15 gigawatt hours. If we restricted ourselves to the base unit of watt hours, it'd be 1,150,000,000 watt hours. Okay, that wasn't too hard, was it? You should be well versed in reading numbers as displayed on the TI89 using engineering format, where again it's 3 parts: a coefficient, an e, and a power of 10. Now, let's stand this concept on its head, and rather than reading numbers, let's learn to enter numbers into the calculator using engineering format. You'll be happy to know that entering numbers in engineering format is just as easy as finding a sketchy neighborhood in Detroit. You can't not enter a number in engineering format when the TI89 is in engineering mode. That's the point of having an engineering mode. It takes any confusing pile of numbers you enter, chops it up, and displays it in an easily readable manner. As long as you're entering the right number, you can enter this number in any fashion you see fit, and the calculator will immediately recognize to what power of 10 it needs to raise to make it the most readable. For example, consider the number 68 kiloohms. This is 68 times 10 to the third, or 68 times 1,000, or 68,000 ohms. I can enter 68,000 into my calculator by entering 6, 8, 3 zeros and follow it up with an enter key. The calculator returns 68E3, meaning it has gone to the trouble of converting it to engineering format using its own peculiar display method. This method works, but entering long strings of zeros is a serious pain, so often enter them using shortcuts using the power of 10 or EE key. If I enter 68EE3, the calculator recognizes that I want to multiply 68 times 10 raised to the third power, or 1,000. Press enter. This also yields 68E3. How easy is that? But wait, there's more. Even if you enter the number in some weird alternate fashion, let's say scientific notation, the calculator will do the conversion to engineering format for you. 68,000 in scientific notation is 6.8 times 10 raised to the fourth. If I enter 6.8 EE4, the calculator still spits back 68E3. As long as your calculator is set up in exponential format engineering using the mode key, you will never have to worry about this again. The calculator puts any number you enter into engineering format. Consider the following selection of numbers. By all means, pause the lecture and punch these numbers into your calculator using whatever method you wish and press enter. If you're in exponential format engineering, you should get the following results. 6.75 megawatts could be represented as 6.75 times 10 to the 6, or 6,750,000. If you wanted to, you could enter 6, 7, 5, 4 zeros and press enter. The calculator would return 6.75E6. Although effective, this is inefficient. Go straight into engineering format. 6.75 megawatts is 6.75 times 10 raised to the 6. Enter this as 6.75 EE6. Again, the calculator returns 6.75 E6. Same results with less keystrokes. That's the point of engineering notation. It makes unusually large and unusually small numbers less cumbersome and easier to manipulate. 33 microfarads could be represented as 33 times 10 to the negative 6, where 10 to the negative 6 is 0.000001. If you wanted to, you could enter decimal point, 4 zeros, 33, and press enter, and the calculator would return 33 E negative 6. Again, this seems super inefficient. Enter it in engineering format. 33 microfarads is 33 times 10 raised to the negative 6. Enter this as 33 EE negative 6. Again, the calculator returns 33 E negative 6. Same results, only faster. Just for the heck of it, let's enter 4,500,000 hertz in long form. 4-5 followed by a shit ton of zeros. 4,500,000 hertz is 4.5 times a million, or 4.5 megahertz. Alternatively, we could have entered this as 4.5 EE6. Either method of entry results in 4.5 E6 being displayed on the calculator. Finally, 2.56 times 10 to the negative 7th is a number expressed in scientific notation. For those with some experience in scientific notation, you'll realize 10 to the negative 7 is a shift 7 decimal places, meaning this number is 0.000000256 when expressed in the base units of grams. You can go to the trouble of learning scientific notation and laboriously enter it as 0.000000256. However, we are not training to be scientists. We're training to be engineers and technicians. Not only do we get paid better than scientists, we're better looking, and we use engineering notation to get the job done. It's far faster to enter it directly in the format you've been given as 2.56 EE negative 7, and that calculator takes the junky scientific format and properly reformats it, as would a good-looking, high-paid engineering technician, as 256 E negative 9, or using engineering prefixes, 256 nanograms. Thank you, calculator. Your work here is done. Last quick note before we go. While in exponential format engineering, the TI89 will display all fractions in engineering format. For example, 1/2 is 0.5. The TI89 will display 0.5 as 500 E negative 3, which means 500 times 10 to the negative 3rd, or 0.5. Similarly, 1/4 is 0.25. The TI89 will display 0.25 as 250 E negative 3, or 250 times 10 to the negative 3rd, or 0.25. Those unfamiliar with engineering format might be a little taken back by this at first, but it makes sense. While in exponential format engineering, the TI89 displays every number you throw at it in engineering format. That's it. This concludes the short introduction to engineering notation as implemented on the TI89. We'll be making use of these skills all day, every day, for the rest of your life, so get good at it now. If you're less than confident with your ability to write and read engineering notation on the TI89, I'm asking you to get confident in these skills before moving on to the next topic. By all means, rewind and revisit this lecture as many times as you need. Practice, practice, practice. Engineering notation and the scientific calculator may be entirely foreign to you, but trust me, just like learning a new language, it'll get easier and more natural with repeated exposure. In conclusion, this lecture took a look at engineering notation as implemented on the TI89. We learned to set up our calculator using the mode key and place it in engineering format. Then we learned to interpret and enter numbers in engineering format. Remember to review this material as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.